Hello students, we are going to start the chapter solutions. What is the definition of the solution? It is nothing but the mixture of two or more components or constituents. And according to the number of components, you have binary fissions. If you are having two components, then it is called as binary solution. If three, ternary, if four, quaternary. In this chapter, we will only deal with the binary solution. Now, type of solution. According to the nature of the solution, we can have solid solution, liquid solution, and gas solution. What will be the solute and solvent? Solute will be, in case it can be solid, liquid, and gas. Similarly, in case of liquid, solid, liquid, and gas. In case of gas also, solid, liquid, and gas. Solvent, if the natural solution is solid, the solvent will be solid in all cases. In case of liquid, it will be liquid. Then in case of gas, it will be gas. Now example, solid and solvent, it is what? Alloy. Solid in liquid, mercury amalgam. Then gas on solid, that is if any gas it get absorbed on metal, it will be the example. Now liquid in solid, the simple salt plus water or sugar plus water. Liquid in liquid, alcohol plus water. Liquid in gas, carbon dioxide plus water, that is aerated drinks. Gas in solid, iodine vapor. In air, gas in liquid, humidity in air, and gas in gas is what? Air, that is mixture of gases. I hope you have understood. Then next topic is how to express the concentration of the solution. Expressing the concentration of solution. What is concentration of solution? Amount of solute that is present in a given quantity of solvent or solution. So we can describe it, the concentration, in terms of qualitative as well as quantitative. Qualitative means you will say it as dilute or concentration. If the solute is small amount, then it is dilute solution. If solute is in large amount, we will call it as concentrated solution. Now we are going to study quantitatively. First is mass per person, mass percentage, sorry, mass percentage. So this can be weight by weight or volume by volume. So first weight by weight, that is the mass of the component per 100 gram of solution. So if we have two components A and B, let the mass is WA and WB. So mass percentage of A will be WA upon WA plus B into 100. Similarly, of B will be what? WB upon WA plus WB into 100. So if we say 10% of glucose, so what it will be? 10 gram of glucose plus 90 gram of water. Now volume by volume, it will be what? 100 parts of component, that is per 100 parts of by volume of solution. Parts by volume of solution. Same way we can find out the mass volume percentage of A and B. A will be VA upon VA plus B into 100. Similarly, we can find out B, VB upon VA plus VB. Concentration can also be expressed, the mass percentage, as W by V, that is weight by volume. So this is used in pharmacy and medicine. So 10%, suppose you say KCl, it will be 10 gram of KCl in 100 ml of solvent. First was mass percentage. Second, how to express the concentration? You can express parts per million, that is P, in short, ppm. So if you want to express the concentration, if the solute is in very small amount, in traces, then this is used. It is parts of the component per million parts of solution. Per million parts of solution. That is equal to ppm is equal to mass of component upon total mass of solution into 10 to the power 6 million, that's why 6 10 to the power 6. So suppose we have 1 liter of seawater. If it weighs 1030 gram and contains 6 into 10 to the power minus 3 gram of dissolved oxygen. So how you will find out the ppm of oxygen? It will be 6 into mass of the component, 6 into 10 to the minus 3 the gram, divide by 1030, that is the total mass of the solution, into 10 to the power 6, that comes to be 5.8 ppm. So this is also used where there is air pollution. This unit is used, that is, if we say 100 ppm of oxides of nitrogen means 100 parts by volume of nitric oxide, it is present in 10 to the power 6 part of by volume of air. Third, that is molarity. You studied in class 11th also this molarity, denoted by capital M. Definition: number of moles of solute dissolved per liter of the solution. So formula: gram moles of solute divided by volume of solution in liter. So moles of solute, if you have WB and MB. What is WB? Mass of solute. MB is molar mass of solvent. Then gram mole will be what? And WB by MB. Volume is V, and if you multiply it by 1000 it will be liter. So capital M, that is molarity, the formula will be WB upon MB into 1000 into B. So we will be solving some numericals also on molarity. I hope you have understood. Then next is molality. Molality is denoted by small m. So number of moles of solute dissolved per 1000 gram of, or we can say 1 kg of solvent. Denoted by small m, so m will be equal to gram moles of solute divided by mass of solvent in kg. So formula will be what? Similarly you can find out, m is equal to, you can make the formula WB by MB into 1000 into WA also. What is WA? It is the mass of solvent in, that is kg. Again you will be using this formula for numericals. Now you have seen both small m and capital M, that is molality and molality. What is the difference between the molality and the molarity? Here you are using mass, the solvent is in mass, here solvent is in volume. You know that volume changes with temperature, therefore the concentrated solution will change with the temperature. Here it does not change with the temperature. So which one will be the more better unit method for using the concentration, finding out the concentration? It will be molarity. I hope you have understood. Next is mole fraction, the last method of concentration, expressing concentration. Mole fraction is, so it is nothing but the ratio of number of moles of one component to the total number of moles of all components. Means it will, how many components are there in a solution, so you will make the total. So ratio of the number of moles of one component divided by the total number of moles of all the components, and it is denoted by x. So for binary solution, if you have two components XA and XB, then if number of moles is Na for component A, so the mole fraction for A will be Na upon Na plus Nb. For mole fraction for B component will be Nb upon Na plus Nb. And for a binary solution, the total number of XA plus XB will be equal to Na upon Na plus Nb plus Nb upon Na plus Nb. And this is always equal to 1. XA plus XB is equal to 1. So if you know the mole fraction of one component, you can just subtract it from the other component. That is, if you want to find out XA, then 1 minus XB will be the formula, and if you want to find out XB, then it will be 1 minus XA. Suppose if we have I number of components, so XA will be equal to Na plus Nb plus Ni, or you can write Na upon summation Ni. Similarly for XB, Na upon Na plus Nb plus so on, it will be Nb upon summation Ni. So in general you can write x to the power, means for I components, Ni upon summation Ni. And you can show that x1 plus x2 plus x3 and so on xi, it will always be equal to 1. So these were the methods of finding out the concentration. Then there are numericals for this. It's important. Numericals are asked. So let us start the numericals topic wise only. First we have studied about the mass percentage. So one example for the numerical, if we have 11 gram of oxalic acid and if it is dissolved in 500 ml of solution, and if density is given as 1.1 gram milliliter inverse, then we have to find out the mass percentage of oxalic acid solution. So mass of solution you can find out how. Just multiply 500 ml into 1.1. It comes to be 550 gram. So mass percentage of oxalic acid will be 11 gram is given, divided by 550 into 100, comes to be 2%. Then based on molarity, a numerical. I hope you have understood this. Molarity. Suppose it is given 2.46 gram of NaOH is given. It is dissolved in water and the solution is made to 100 centimeter cube in a volumetric flask. Calculate the molarity. You have to find out the capital M. So for this, you have to find out the molar mass of NaOH. It is, you can calculate, and it will be equal to 40 gram. So first, moles of NaOH. Mass of NaOH given 2.46 divided by 40. It comes to be 0.0615 mole. So M will be equal to 0.0615 divided by volume is given 100 ml into 1000. So it will be 0.615. Unit will be mole per liter, mole liter inverse, or you can also write capital M. Next, molality. You have to find M. If 20% of 7 gram of K2CO3 is dissolved in 500 ml, density given is 1 gram milliliter. So mass of K2CO3 20.7. You will require molar mass. If we will find out, it comes to be 138. So moles of K2CO3 20.7 divided by 138. So before that you have to find out the amount of water. Density is given, so mass of solution will be 500 ml into 1 gram, that is 500 gram. So from the 500 gram you have to subtract 20.7, then you will get the amount of water, that is 479.3 gram. So small m will be moles of solute divided by, that is 0.15 mole. This comes to be 0.15 divided by 479.3 into 1000. Answer is 0.313 small m or mole per kg. Now if all the things are given, to calculate the molarity and mole fraction also, then so the question is calculate molarity, then mole fraction of Ki, density of 20% of aqueous Ki is 1.202 gram per milliliter. So if 20% is given, means mass of Ki will be equal to how much? 20 gram. Mass of solution in water will be 100 gram. So mass of solvent in water will be, mass of solvent will be 100 minus 20, that is 80 gram. So first you have to find out the moles of Ki. that is 20 gram divided by Ki. The molar mass is 166. It is equal to 0.120. So molarity, first part here, molarity will be 0.120 upon 80 gram is the mass of solvent into 1000, that is equal to 1.5 mole per kg. Then second, molarity. Moles of solute 0.120 divided by you have to find out the volume of solution. Let us do again molarity. Molarity, volume of solution. It is given what mass of solution is 1000 grams, so we have to divide it by density. Mass upon density is volume. It comes to be 83.2 ml. Now you can find out the molarity, that is equal to moles of solute 0.120 divided by 83.2 ml into 1000. That comes to 1.44 m, capital M. Now mole fraction. For mole fraction you have to need the moles of two components, that is Ki as well as water. This we have find out, that is 1.20, you know. Moles of water will be mass of water 80 gram divided by 18, that is 4.44. So mole fraction, that is Xki, will be equal to number of moles of one component, that is 0.12420 divided by 0.120 plus 4.44. So the answer is 0.0263. So in this way we have calculated molarity and mole fraction. Hope you have understood. So homework, the numericals that is given in your textbook of page, let me see the page, page 37. 5 numericals are given, so you have to do 5 numericals. That's all for today.